So today we'll see review of inverse Laplace transform. In our previous classes we were discussing about Laplace transform, and today we'll see inverse Laplace transform. That is, you will be given a Laplace transform function. From there you will have to find out the original function. So in order to find out the inverse Laplace transform, it is very necessary that you should know the standard results. So let's quickly review the standard results which we have learned. Laplace transform of delta of t is 1. Laplace transform of u of t is 1 by s. Laplace transform of r of t is 1 by s square. Laplace transform of e raised to minus at u of t is 1 by s plus a. T into e raised to minus at u of t is 1 by s plus a the whole squared. E raised to at u of t is 1 by s minus a. Then Laplace transform of sine omega naught t is omega naught by s square plus omega naught square. Laplace transform of cos omega naught t is s by s square plus omega naught square. Then e raised to minus at sine omega naught t. You can apply the frequency shifting property. So all s should be replaced by s plus a. S plus a the whole squared plus omega naught squared. Similarly, e raised to minus at cos omega naught t will be s plus a by s plus a the whole squared plus omega naught squared. So these are the standard results which will help you to find out the inverse Laplace transform. The question is, find inverse Laplace transform of x of s equal to s by s plus 2 the whole square. Now there are two methods to solve this. The first is by using the property and standard results. Now we know that one by s plus a the whole squared is a standard result. 1 by s plus a the whole squared is the inverse Laplace transform of e raised t into e raised to minus at u of t. Here a is 2. So t into e raised to minus 2t u of t. And we also know the property that s into x of s is the Laplace transform of d by dt of x of t, right? So here you are multiplying s with 1 by s plus 2 the whole square. You have multiplied s with 1 by s plus 2 the whole square. So this will be d by dt of what? X of t. What is x of t? X of t is t into e raised to minus 2t u of t. Now we can evaluate this. What is d by dt of t into e raised to minus 2t u of t? This is equal to first into derivative of second, that is minus 2 into e raised to minus 2t u of t plus e raised to minus 2t u of t. Or you can take e raised, this can be written as e raised to minus 2t into 1 minus 2t u of t. Now this u of t, if you don't write u of t also, it's fine. So this is the inverse of s by s plus 2 the whole square. E raised to minus 2t into 1 minus 2t u of t. So I'll explain once more what I have done is, now whenever we see a s in the numerator, it falls under this property, s into x of s. So take the function other than this s. So it is 1 by s plus 2 the whole square. That is a standard result. We can directly write its inverse, which is t into e raised to minus 2t u of t. Now in order to get s by s plus 2 the whole square, it should be d by dt of this result. D by dt of t into e raised to minus 2t u of t. So you perform this differentiation, you will get the answer. Now there is another method to do this, that is, you are given the function x of s equal to s by s plus 2 the whole square. Okay. Now I am going to add and subtract 2 in the numerator also. That is, I am going to convert this function to a known standard result. So for that, here the coefficient is 2. So I am going to add and subtract 2 in the numerator. Okay. I am going to split this into 2. So that will be s plus 2 by s plus 2 the whole square minus 2 by s plus 2 the whole square. And this is equal to 1 by s plus 2 minus 2 into 1 by s plus 2 the whole square. This is x of s. This is now in standard forms. We can directly write down the inverse. X of t equal to, what is inverse of 1 by s plus 2? It is e raised to minus 2t u of t minus 2 into 1 by s plus 2 the whole square is t into e raised to minus 2t u of t. Or we can write it as e raised to minus 2t 1 minus 2t u of t. So in both the cases we have used the standard result. This one, t into e raised to minus 8t u of t is 1 by s plus a the whole square, and I'll write that. The standard results which we have used is e raised to minus 8t u of t. Laplace transform is 1 by s plus a, and another standard result which we have used is t into e raised to minus 8t u of t is 1 by s plus a the whole square. So thus we have found the inverse Laplace transform by two methods. Another question. Find inverse Laplace transform of x of s equal to s by s minus b the whole squared plus a squared. So whenever we get a function, to find its inverse, our first step is you should identify the standard results which is somehow related to this given function. Now here it is given as s by s minus b the whole square plus a square. Now the known standard functions of these forms are e raised to minus at sin bt is b by s minus a the whole squared. Okay, wait, I'll change this constants. E raised to minus bt sin at will be a by s minus b the whole squared plus a squared. Also, another standard result is e raised to minus bt cos at will be s minus b by s minus b the whole squared plus a squared. So these are the two standard results. So our aim should be to express the given function, or you have to rearrange this given function somehow so that it can be compared to the standard equation. So here we see that either a should come in the numerator or s minus b should come in the numerator. Here there is just s, so we can add a plus b and a minus b. So let's do that. Now this is the standard result. So I am going to convert our x of s. I am going to add a plus b and a minus b. So it will be s plus b minus b by s minus b the whole square plus a square, or this can be s minus b by s minus b the whole square plus a square minus b by s minus b the whole square plus a square. Correct? Now this is in standard form already. S minus b by s minus b the whole square plus a square. Now what about the second one? Here it is b, but in the standard result it should be a. So what can be done? Let me write this as such. This is already in the standard form, so there is no need to change that. Minus, here there should be a. So I can multiply and divide a in the numerator. So it will be b by a into a whole divided by the denominator. S minus b the whole square plus a square. Now both are in the standard form. We can find the inverse. X of t is equal to, the first one is s minus b by s minus b the whole square plus a square will be e raised to minus bt cos at minus b by a is a constant into a by s minus b the whole square plus a square is e raised to minus bt sin at. So this is the answer. Okay, here it is plus b, sorry. S minus b is taken here, so plus b. Final result also it is plus b. Next question. Find inverse Laplace transform of x of s equal to s squared plus 3s plus 4 the whole divided by s cube plus 5s squared plus 7s plus 3. Okay. So this problem is different from the ones we have already done. Here you cannot compare this to any standard results. Here a polynomial fraction is given, that is a numerator polynomial and a denominator polynomial. So we have to find out the inverse Laplace transform by performing partial fraction. And there is a basic condition so that we can apply partial fraction. The highest degree of numerator should always be less than the highest degree of denominator. Only if that particular condition is satisfied, we can apply partial fraction. Here the highest degree of numerator is 2, highest degree of denominator is 3. So the condition is satisfied. Denominator polynomial is at a higher degree compared to numerator polynomial. So the first step is we have to express the denominator in terms of factors. So we have the polynomial x cube plus 5s squared plus 7s plus 3. Now there are different ways in which we can find out the factors. I will be explaining one technique. Here by trial you find out one factor. Now suppose s equal to minus 1. What will be the value of this polynomial? It will be, when s equal to minus 1, it will be minus 1 plus 5 minus 7 plus 3, which is equal to 0. That is, s equal to minus 1 is one factor. So the first factor is obtained by trial and error method. And whatever value of s satisfy the equation equate to 0, then that is one factor. Once we get one factor, we can find the other by, you take the coefficients of this 1, 5, 7, 3. One factor we got is minus 1. The first, you just take it down. 1 into minus 1 is minus 1. 5 minus 1 is 4. 4 into minus 1 is minus 4. 7 minus 4 is 3. 3 into minus 1 minus 3, which will be 0. So this can be written as s square plus 4s plus 3. Okay, which can be expressed as factors as product should be 3, sum should be 4. So s plus 1 into s plus 3. One factor was s equal to minus 1. So we can express this polynomial s cube plus 5s squared plus 7s plus 3 as s plus 1 into s plus 1 into s plus 3, or this can be written as s plus 1 the whole squared into s plus 3. So thus we have expressed the denominator polynomial in terms of factors. So what will be x of s? X of s can be written as s square plus 3s plus 4 the whole divided by s plus 1 the whole squared into s plus 3. Now we can perform partial fraction. This is equal to a by s plus 1
b by s plus 1 the whole squared plus c by s plus 3. Or we can compare the numerators equal to a into s plus 1 into s plus 3 plus b into s plus 3 plus c into s plus 1 the whole square. We can expand this and compare the coefficients and find out the values of a, b and c. We will get a equal to we will get a equal to 0, b equal to 1 and c also equal to 1. Okay, so x of s can be written as a is 0, so this term will go, b is 1 by s plus 1 the whole squared, c is also 1 by s plus 3. Now this is in standard form. We can find the inverse x of t equal to, this is t into e raised to minus t u of t plus e raised to minus 3t u of t. This is the answer. Next question. Find inverse Laplace transform of x of s equal to s plus 1 the whole divided by s cube plus 4s squared plus 6s plus 4. So again, polynomial function is present in both numerator and denominator. We have to perform partial fraction. The highest degree of denominator is 3 and that of numerator is 1. So we can directly apply partial fraction. So let's find out the factors. S cube plus 4s squared plus 6s plus 4. Now if I substitute s equal to minus 1, this won't be equal to 0. Let's substitute s equal to minus 2. So it will be minus 8 plus 2 squared 4, 16 minus 12 plus 4. So this will be equal to 0. So one factor is s equal to minus 2. Now to find the other terms, this is 1, 4, 6 and 4 minus 2. 1 into minus 2, 4 minus 2 is 2, 2 into minus 2 is minus 4, 6 minus 4 is 2, 2 into minus 2 is minus 4, this is 0. So this can be written as s squared plus 2s plus 2. Okay. So this cannot be further factorized. So s cube plus 4s squared plus 6s plus 4 can be written as s plus 2 into s squared plus 2s plus 2. Thus, x of s can be expressed as s plus 1 the whole divided by s plus 2 into s squared plus 2s plus 2. Now, this can be written as a by s plus 2. This should be expressed in the form of bs plus c, because you cannot factorize this further by s square plus 2s plus 2. Okay. Now you can compare the numerators. S plus 1 equal to a into s square plus 2s plus 2 plus bs plus c into s plus 2. You can expand this, compare the coefficients, and you will get the values as a equal to minus 1 by 2, b equal to 1 by 2, and c equal to 1. So, we can express x of s as x of s equal to minus 1 by 2 by s plus 2 plus 1 by 2 s plus 1 by s square plus 2s plus 2. Now to convert this to standard form, let's write it as, this is already in standard form, so no need to change that. Minus 1 by 2 into s plus 2 plus 1 by 2 s plus 1 by, we can express this as x plus 1 the whole squared, which is s square plus 2s plus 1, the remaining is 1, so it can be written as this. Okay. Now I am slightly going to change the numerator of this. If I am taking this 1 by 2 common, okay, I'll write it as the next step. This is equal to minus 1 by 2 by s plus 2 plus what I am going to do is, I am taking 1 by 2 as common. So it will be 1 by 2 s plus 1 by 2. But here it should be 1. So that 1 by 2 I am writing it separately. So now the numerator is same. Divided by s plus 1 the whole squared plus 1. Okay. Now you can split that into two different terms. That is, x of s can be written as minus 1 by 2 by s plus 2 plus 1 by 2 into s plus 1 by s plus 1 the whole square plus 1, which can be written as 1 square also. Then the last term plus 1 by 2 by s plus 1 the whole square plus 1 square. Now all these are in the standard form. We can find the inverse. This is minus 1 by 2 into e raised to minus 2t. You can write u of t or neglect it, doesn't matter. Plus 1 by 2 into, what is s plus 1 by s plus 1 the whole square plus 1 square? It is e raised to minus t cos t plus 1 by 2 into 1 by s plus 1 the whole square plus 1 square is e raised to minus t sin t. If you want, you can put a whole bracket and write u of t outside. This is the final answer. Next question. Find inverse Laplace transform of x of s equal to s square plus 5s plus 1 the whole divided by s square plus 3s plus 2. So here both the numerator and denominator are of same degree.
So you cannot directly apply partial fraction. What we do is we'll divide this s square plus 5s plus 1 divided by s square plus 3s plus 2. So it will be 1 s square plus 3s plus 2, which will be 2s minus 1, or the function s square plus 5s plus 1 by s square plus 3s plus 2 can be written as 1 plus 2s minus 1 divided by s square plus 3s plus 2. Okay, now we'll take this term alone and apply partial fraction. So let this be x1 of s. Okay, so x1 of s equal to 2s minus 1 by s square plus 3s plus 2. This is equal to 2s minus 1 by product should be 2 and sum should be 3, so it should be s plus 1 into s plus 2, which can be written as a by s plus 1 plus b by s plus 2. Can equate the numerator. So we'll get 2s minus 1 equal to a into s plus 2 plus b into s plus 1. On solving this, we'll get a equal to minus 3 and b equal to 5. So we can write x of s equal to, the 1 was there, 1 plus x1 of s is a by s plus 1. A is minus 3. So minus 3 by s plus 1. B is 5. 5 by s plus 2. Now this is in standard form. X of t equal to 1 is Laplace transform of delta of t minus 3 into e raised to minus t u of t plus 5 into e raised to minus 2t. This is the answer. So before doing partial fraction, just compare the degree of numerator and denominator. We can apply partial fraction only if the degree of numerator is less than the degree of denominator. Another question. Find inverse Laplace transform of x of s equal to 1 plus e raised to minus 2s divided by s square into s plus 1. So here we'll split this into two terms, that is 1 by s square into s plus 1 plus e raised to minus 2s by s square into s plus 1. This is x of s. Now let me write the first term as x1 of s and second term as x2 of s. So first let's take the first term alone. x1 of s equal to 1 by s square into s plus 1. Now we can perform partial fraction of this. This can be written as a by s plus b by s square plus c by s plus 1. Or equating the numerators, we'll get 1 is equal to a s into s plus 1 plus b into s plus 1 plus c into s square. Now let s equal to 0. When s equal to 0, this term will tend to 0. This will reduce to 0. So it will be 1 is equal to, s is 0. So 1 is equal to 0 plus 1, 1. Or we'll get b equal to 1. Similarly, substitute s equal to minus 1. When s equal to minus 1, this term will reduce to 0. This will also reduce to 0. S minus 1 the whole squared is 1. So we'll get 1 is equal to c. So c also we'll get as 1. Now to find out a, let's substitute s equal to 1. So left hand side is 1. 1 is equal to a into 1 plus 1 is 2. So a into 2 plus b is 1. 1 plus 1 is 2. So 2. C is 1. 1 square is 1. So plus 1. Or we'll get a equal to minus 1. So we got all the three variables a, b and c. So x1 of s can be written as, x1 of s can be written as, you can substitute for a, b and c. A is minus 1. So minus 1 by s. B is plus 1. 1 by s square. And c is also 1. 1 by s plus 1. This is x1 of s. Okay. Now what is x2 of s? x2 of s is the same denominator, but the numerator is multiplied with e raised to minus 2s. So you can write it as e raised to minus 2s into all these terms. Okay. Now if this is x1 of s, what will be its inverse x1 of t? Minus 1 by s. 1 by s is standard form of u of t. So it is u of t. 1 by s square is ramp function, which can otherwise be written as t into u of t. And 1 by s plus t is e raised to minus t u of t. Or we can take all the u of t outside. So 1 plus t plus e raised to minus t into u of t. This is x1 of t. Okay. Now Laplace transform of 1 by s is u of t. Okay. Inverse Laplace transform of 1 by s is u of t. Then what will be the inverse of e raised to minus 2s into 1 by s? It is time shifting property, right? What was time shifting property? X of t minus t naught is e raised to minus s t naught into x of s. So if u of t is 1 by s, then what will be the inverse of e raised to minus 2s 1 by s? U of t shifted by 2 units. Correct? U of t minus 2 will be e raised to minus 2s into 1 by s. So when I write down the inverse of x2 of s, we'll get it like, if I am going to write x2 of t, it will be the same thing, but all t should be replaced by t minus 2. Why? How did we get t minus 2? T minus 2 because of this shift. So when you see a exponent term in the s domain, it means in the time domain there is a shift. By how many units? By 2 units. So from x1 of t we can write down x2 of t. Equation will be the same. Only difference is all t will be replaced by t minus 2. So what will be x2 of t? It will be 1 plus t minus 2 plus e raised to minus of t minus 2 into u of t minus 2. So our final answer is x of t equal to x1 of t plus x2 of t, which is 1 plus t plus e raised to minus t u of t plus 1 plus t minus 2 plus e raised to minus of t minus 2 into u of t minus 2. So whenever you see an exponent term in the Laplace function, we should know that it corresponds to a time shifted function in the time domain.